All right, guys. So we're going to do 6.3 here now, and it looks like we might be having to do this virtual thing for a while longer. So if you do want to print out these study guides, they are posted on Google Classroom already. If you go to Google Classroom under Classwork tab, there's a section that's called Note Guides, and they're all under there actually in PDF form, so you can print them out. If you don't have a printer though, or you don't want to do that, you're welcome to continue taking notes just on a regular plain sheet of paper and any notebook that you have. It's really not going to make a difference. The main thing is that you are taking notes of some format. Notes are very important for math class, and I let you use them on your test and on your final, so you really want to make sure that you have this written down. Since this is a video, definitely take your time, pause it if you need to, so you can have some extra time to write things down. Trying to make these fairly short though, just for internet's sake, okay? So in 6.3, we're going to talk about arc. So an arc is actually a portion of a circle. A portion of a circle. So basically, if I were to draw not a full circle, but any portion of a circle, whether it's a short portion or a really long portion, that is what we would call an arc. So it's like a segment in the fact that it has two endpoints, but it's curved and not straight. And it's not any curve. The curve does have to follow a perfect circle. So my arcs here aren't exactly perfect. I don't think they follow a perfect circle at all. But that is important for an arc. An arc needs to follow an actual circle. The circle can be any size, but that's what determines the kind of like the curvature of that arc. So, like I said, a line segment, we've seen line segments before. A line segment is a part of a line and it is straight. So I can draw a line segment here. I can label the endpoints A and B, and then I could tell you the name of this segment is segment AB, or we could name it segment BA, right? Well, with a arc, it's very similar. It also has two endpoints, but it is curved, not straight. It is actually a part of a circle. So if I draw an example of an arc down here, and I label its endpoints, I could name this arc, arc AB. Actually, I think it needs to be a little shorter for that, arc AB. And again, we can reverse those two letters and call it arc BA. So notice my names of this arc is very similar to how we write the name of a segment, but the hat on top is curved. So the curved hat indicates that this is the name of an arc with endpoints A and B. Things that they have in common. Both segments and arcs have two endpoints. I labeled them both A and B in this case even. And both an arc and a segment include all the points between those two endpoints. That's kind of what makes that line. And we can measure these things. An arc also has a length that can be measured. Okay, we're not actually going to measure the length of an arc in this section. We'll get to that in 6.7, which is the next one we will cover. But for now, just know that arcs do have lengths. Okay, so there are four very important terms that we're going to talk about in this section. The first is a central angle. A central angle is an angle whose vertex is the center of a circle and whose sides are two radii. And again, you can pause this if you're writing this by hand. Give yourself some extra time to write this down. So I give you an example of a central angle. If I have a circle, and this is the center, then any angle whose vertex is on that center would be called a central angle. So I could label this angle here, angle A, B, C is a central angle. And then we have two types of arcs actually. There's a minor arc and there's a major arc. So a minor arc is an arc that's created by a central angle and it lies inside the two sides of that central angle. Whereas a major arc is also created by a central angle, but it lies outside the two sides of that central angle. So again, if I draw a picture of a circle here, and I draw, and here's a center, and if I draw any central angle in here, I'll draw a central angle over here this time. Make it a little bigger, maybe. Not that it matters. So if this is my central angle here, then I actually have two arcs that are formed. The arc in the inside of this central angle here is called the minor arc. And the arc outside of that central angle is called the major arc. So you can see the major arc is the big arc. The minor arc is your small arc. And then, of course, we have kind of the in-between, a semicircle. A semicircle is an arc that covers half the circle. So again, if I draw a circle, and here's the center, and I draw a central angle that is actually a straight line, a straight angle, we end up with two arcs again, but both arcs are neither minor nor major. They are semicircles. So we end up with two semicircles. So before I talk about this part, let me move down here and talk about how we name a arc. So again, I'm going to draw a picture of a circle and its center. And I'm going to draw a central arc that's not a straight angle right here this time. So here's my central angle. Okay, when I have that central angle, again, I have two arcs that are formed, a minor arc and a major arc. So how do I name these two arcs? So suppose the endpoints of this central angle are A and B. Then the name of this minor arc will be arc AB, or arc BA. But I can't call the major arc the same thing because it's obviously a very different arc. So for major arcs, I actually need one more thing. To name a major arc, I need one additional point that is on that major arc. And that additional point can be anywhere on my major arc. Suppose I have a point I know about right here. Maybe it's point D. Now I can see that my major arc's name is arc ADB, or I can call it arc BDA. So if you see an arc name and there are 3 letters, you automatically know that you're looking at a major arc. We only include a third letter if I'm looking at a major arc or a semicircle. If I'm looking at a minor arc, there will only be 2 letters in the arc's name. So on this page here, you can go ahead and draw these pictures. Go ahead and pause the video if you need to draw these pictures. It shouldn't take too long. Notice in each of these pictures, we have something highlighted. In this case, the piece that's highlighted in blue is a central angle. It's an angle whose vertex is at the center point C. And how do I name an angle? Back to Unit 1, I would call this angle ACB, or I could call it angle BCA. On this one, my highlighted part is the arc between points A and B inside our central angle. So that is a minor arc. And its name is arc AB, or we could call it arc BA. I only need 2 letters here because it is a minor arc. On this one, the highlighted part in blue is a major arc. And since it's a major arc, I need to use 3 letters in its name. So I can call it arc A, X, B, or I could call it arc B, X, A. And on this one, we have a semicircle. You can see we actually have 2 semicircles in this diagram. I could look at this one as well. And both of semicircles have endpoints A and B. So you can see, again, it's not reasonable to call this semicircle in blue just AB arc, because there are 2 AB arcs in this diagram, and neither of them are minor arcs. So this is a semicircle. And to identify the blue arc, I would say we're looking at arc A, X, B. So both major arcs and semicircles need to have 3 letters in their name. Now let's talk about a measure of an arc. So one thing I want to be clear of is this is not representative of the length of an arc. Arcs do have lengths, and we will learn about how to calculate an arc's length in the next section that we cover. Here we're talking about an arc measure. And when you hear the word arc measure, you should think angle measure. Because an arc measure is actually going to be equal to the corresponding central angle measure. So for a minor arc, it is always going to be less than 180 degrees. A semicircle will always be exactly 180 degrees. A major arc will always be more than 180 degrees. And a full circle, which is also an arc, is exactly 360 degrees, no matter how big or small the circle is. Again, the measure of an arc is not equal to the length. Measures are measured in degrees. Lengths are going to be measured in things like centimeters or inches or feet. Okay, so if we're looking for the measure of a minor arc, it will always be equal to the measure of the central angle that intercepts it. If I add up any minor arc with its corresponding major arc, we end up with a measure of a circle, 360 degrees. Think of it this way. Here's my circle. Here's my central angle. So if my central angle here is, say, 70 degrees, then that would mean that my minor arc here is also 70 degrees. My whole circle has to be 360 degrees, so my major arc is going to be whatever's left of 360 after I subtract the 70 degrees on the minor arc. 360 minus 70 is 290 degrees. So my major arc is 290, my minor arc is 70, and 70 plus 290 gives me in my whole circle's measure 360 degrees. Let's do some more problems like that. Here we have a diagram. The first thing it asks us to find is a measure of the central angle ACB. The measure of angle ACB is already given to us in our diagram. It is 120 degrees, which means the measure of our minor arc AB, is going to be equal to that central arc. It will also be 120 degrees. And the measure of my major arc needs to be what I would add to this to get a full circle. 120 plus 240 is 360. So my major arc has to be 240 degrees. And the measure of any full circle is always 360 degrees.